Hello, Math Analysis. So we are only going to be doing this first page of notes, graphing rational algebraic functions. And so let's get into it. I'm going to put an example up here that's different than this one you're given. Let's say I gave you something that looked like this after factoring. So that's going to be the key, that you're going to have to do some factoring with these. But let's take a look at what this different kinds of discontinuities that can occur. So the first one we're going to look at is what I call a removable discontinuity, or what I abbreviate to RD. That's when you have a hole in the graph after you have removed a factor. So for instance, in this example up here, I'm removing the factor x plus 3. So after I graph, I have to go back and leave a hole where x equals -3. You have to show that you cannot divide by 0 even though we removed that factor. So that's your removable discontinuity. That leaves a hole in the graph. What is left is what you would be graphing. So your vertical asymptote, which I abbreviate VA, is going to be the zeros of your denominator after you have simplified. So we would have a 0 at x equals a +1 in that graph. And then your horizontal asymptotes, well, there's two types of horizontal asymptotes. You have y equals 0 if your equation, what you have left, is bottom heavy. That would look something like if I had 1 over x minus 1. That would be bottom heavy because you have a heavier power of x on the bottom than the top. And in that case, y equals 0 would be your asymptote. However, in the equation that we have in our example that we wrote up above, we have the powers of x are the same, top and bottom. When that happens, you take the ratio of those coefficients. And so 2x over x would give me a horizontal asymptote of y equals 2, since that would reduce to 2. And then your x and y intercepts, well, your x-intercepts, that's always going to happen when you just have to set the numerator equal to 0. Because when I set the whole equation equal to 0, if I cross multiply, x minus 1 goes to 0, so you're only setting the numerator equal to 0 to find your x-intercept. The y-intercept, that's going to happen when you let x equal 0, so it's usually the constants in the equation at the end of the equation. All right, let's put this to use with a few examples. So right off the bat, in example A, notice there's nothing to factor, nothing to remove, so I have no removable discontinuity. However, there is an x minus 1 in the denominator, so I have a vertical asymptote at x equals 1. The horizontal, that comes from looking at the coefficients in front of the x, so that's going to happen at y equals 3. These asymptotes are equations of a line, so make sure you write the whole equation, x equals y equals. Don't just write down 1 and 3. And then I want to find my x-intercept. So we let 3x plus 2 in the numerator equals 0. That gives me that x will equal -2/3. And the y-intercept, you just look at the constants, that will be a -2. So now we're ready to graph this. So at x equals 1, we have an asymptote. At y equals 3, we have an asymptote. And then when I put my intercepts on here at -2 on the y, -2/3, so notice those both fall in one quadrant. So I'm going to just follow the asymptote, go through the intercepts, and follow the asymptote. And for the most part, and we can talk about this next time, your graphs are going to be in diagonal quadrants, so I'm just going to then draw a graph over here. And that would be our graph, and we have no hole to have to go back and put in. All right, so we're starting off friendly. Let's get a little more involved. So in example B, I'm going to factor. So I have x minus 3 on top, and then I have a difference of squares that factors into x minus 3, x plus 3. So notice I am canceling out the x minus 3. So I will have a removable at x equals 3. So what I'm actually graphing then is 1 over x plus 3. So I have a vertical asymptote at negative 3. It's bottom heavy, so y equals 0 will be my horizontal. And whenever the x-axis becomes your asymptote, you're not going to have an x-intercept. So you don't have to worry about that. The y-intercept, though, again, I can get that from my original, negative 3 over 9. That simplifies to a 1/3. So I'm going to put that point on the graph. That tells me that I will be in this quadrant, and I will be in this quadrant. Now we have to go back to where x equals 3 and make a little hole there, and now we are complete. So do not forget, because I often do, the hole, because you can't put in the hole on the graph until after you're done graphing. Okay? All right. They get a little more involved each time. So on this example here, notice there's that plus 2. So last year they asked you to rewrite the equations to have that plus 2. You do not have to do that if the instructions ask you to, because I think it's kind of a waste of time. But what we do want to do here is factor what we can. So on top I can pull out a 3. And on the bottom, this is x plus 3, x plus 4, and we still have the plus 2 hanging on. So notice I can cancel my x plus 3, so I know that I have a removable at x minus 3. That also tells me what I'm graphing is 3 over x plus 4 plus 2. So I can see that I have a vertical at x equals negative 4. And then notice that this first equation, first term, is bottom heavy. So that would mean y equals 0, but then you have the plus 2. So whenever you have this like plus something off to the side, that's going to be your horizontal. So y will equal 2, because 0 plus 2 be 2. My x-intercept, now that's going to be a little bit harder with these ones where you have the plus something off to the side. So down here, 3x plus 4 plus 2, I set it equal to 0. So I have 3 over x plus 4 equals a negative 2 over 1, and I cross multiply. So that gives me negative 2x minus 8. So I'm going to have a negative 2x equals 11. So negative 11, negative 11 halves, or negative 5.5 will be my x-intercept. My y-intercept, 9 over 12 is like 3/4 plus 2, so that'll be 2 3/4. All right, so I have all my side things figured out. Let's put our vertical asymptote on here and my horizontal asymptote. And let's fill in where we are going to cross. We're going to cross at negative 5.5, which is right here, and at 2 3/4, which is right above there. So we have a point in each of our two quadrants, so I can just come around, draw my graph, come up, draw the graph. And our last step is to find x equals negative 3. We are going to put the hole on our graph where I think I missed it a little there. There's negative 3. And there's the hole on our graph. Okay, hopefully this is going okay. This is all we're covering is just the basics. So on this last one, now, I definitely wanted to do this one with you because notice the top is, that looks kind of daunting to have to factor. So what we're going to do is factor the denominator first. So that's easy. That's x minus 5, x plus 4. Now with these ones where you have a quite complicated numerator, we are going to figure, oh shoot, one of the signs did not show up. And I'm not sure what that's supposed to be. So I'm going to go look at my original function here. That's supposed to be a plus. For some reason this plus did not come out. All right, so I know that one of the factors in my denominator has to go into the numerator, but I look at this last term, negative 28. 5 does not go into 28, but 4 does. So what I'm going to do is I am going to do synthetic division. So negative 4 would have been the 0 of x plus 4. So I have a 3, 5, negative 28. Bring down the 3, negative 12. That's going to give me a negative 7, and then positive 28. So I know this factors into 3x minus 7, x plus 4. So when you have a difficult numerator, factor the denominator first. Assuming that one of those will be a factor, look at the last term to see which one of your terms will go in. So I can remove x plus 4, which tells me x equals negative 4 will be a removable. I still have my x minus 5, so x equals 5 will be a vertical. 3 over x are the same powers of x, so that's going to be y equals 3. So this is, we're graphing 3x minus 7 over x minus 5 after we removed the x plus 4. So my x-intercept, let the numerator equal 0, so that'll be at 7/3. And then the constants at the end, that'll be a positive 7/5. All right, so let's put our asymptotes and stuff on. So at 5, we have a vertical. At 3, we have a horizontal. And we are crossing at 2 1/3 for the x-axis, so a little bit after 2, and 1 2/5, so here for the y. So they're both in this quadrant, which is fine. So we follow the asymptotes and go through our intercepts, then we'll be in the diagonal quadrant, and we want to go back, and at x equals negative 4, we are going to place a hole on our graph. Okay? So I hope that was helpful, just finding vertical, horizontal asymptotes, removable discontinuities. Sometimes you might have to do some synthetic division, but we're just doing this page today, okay?